Yeah, hello. Welcome to our lectures. Today we are discussing about the subject called IoT system design. So here, this IoT system design is course for the program MTech and the branch of embedded systems. So here we will discuss about the starting philosophy of OBE and also the introduction to IoT systems. So in this regarding this is the presentation contains this presentation contains the course objectives and course outcomes of the course called IoT system design and course syllabus, textbooks and then reference books and also the electronic resources. We have whatever the resources we have for the electronic resources for this IoT system, those we will discuss. And then whatever the modules we have, what are the modules and detailed syllabus of the each module will be discussed here. And then also we will see what is IoT, how it works, and what is the main theme of IoT and why you are studying this IoT and how it is related to our embedded systems, why you are studying this IoT in our embedded systems branch. That also you can cover up here, and what are the real world examples and how this IoT will emerging with the now real world, and then why IoT matters, why IoT means why IoT got that much of importance rather than other subjects, and the IoT ecosystem means how the ecosystem will be built up for an internet of things. So before going to that, already we know that IoT is nothing but an internet of things. Means in the name only you can tell that internet of things. Already we know that internet is nothing but a which is nothing but which is used to communicate any two devices or any two persons or anything will be communicated throughout the far distances, rather than in our previous times we have Bluetooth and like that we have communication through Bluetooth and like. But internet means internet can be done means communicate between throughout anywhere throughout world. So the internet of things is nothing but a connection of different things by using internet. Simply you can say that connection of different things, like any suppose if you come, if you using a mobile phone, the mobile phones to mobile phone is a communication is signal. So like that we have different types. How to build up that ecosystem means for developing an IoT type of ecosystems, what is the structure we will see in that ecosystem. Coming to the course objectives, already we know that already in the BTech level only we already know that what is the course objective and what is the course outcome and what is the course syllabus and all will be see here. So what is the course objective means objective, why you have to study this course, what is the use of by studying this course. So that is nothing but a course objectives. And coming to the course outcomes, if you coming to the course outcomes, what will able to learn from that course means if you study IoT system design, what is the outcome of that course means by studying that course any knowledge or any thing you are getting or not, by these course outcomes we can know that before studying before study the IoT system design only, we are knowing that what is the objective of studying this course and what I will get after studying this course will be the course outcome. And coming to the course syllabus followed by, and coming to the course objectives of this course, if you see student will try to learn what he will try to learn. This objective I told na, what we are studying, what we have to study about that fundamental concepts, evaluation, applications and enabling technologies of the internet of things. What is the fundamental concept we have in the IoT and what are the applications and what are the enabling technologies in the IoT will be studied in the IoT system design subject. And coming to second one, differences, similarities and integration aspects between machine to machine communication and IoT, along with value chains and global perspectives. And coming to the third course objective, basic of Arduino and Raspberry Pi platforms for integrating sensors, actuators and programming in IoT applications. So IoT is not a small thing. IoT is a a huge number of Arduino boards and according to application. So that's why here in the course objective, third objective is we will see the Arduino and Raspberry Pi platforms for integrating sensors and actuators and the programmings. And coming to the architectural components, layers and functional stacks of IoT systems, including data management and computations. And next one is design challenges, emerging pillars and domain specific applications of IoT, such as agriculture, healthcare, transportation, smart cities. Here we will surely done on applications of IoT. And by studying, here we will see the course objectives. Means here we are knowing about that the course objectives, what we will get, by studying IoT system design is deliberated by this slide, and this points 1 2 3 4 5, because we have 5 modules. From each module you will get one objective, and after study, before you're studying only, you are knowing about the course objectives and course outcomes. What we will get after successful completion of the course, students shall able to, means we are know what is IoT and what are the applications of IoT, and whatever the projects you have we can done by using this IoT may be possible because of theoretical knowledge. So coming to here, integrate IoT characteristics, means we will know what are the different IoT characteristics we have. Means suppose if you coming to myself, what is the character of myself? Means I am a teaching professional, I am a associate professor in the department of ECE, like that. Those are the my characteristics. Suppose if I said like that, what is the IoT will do, what are the IoT characteristics will be known. And then what are the enabling technologies? If you come in here, see enabling technologies objectives, here also we will know the enabling technologies in IoT and smart application developments, and analyze the relationship between M to M. M to M is nothing but mission to mission. How the communication is going to be in one mission to another mission by using this IoT, and covering value chains and supporting technologies, and develop basic IoT applications. And in the third module, we will know how to develop an IoT, and by using Arduino and Raspberry Pi and sensor actuator integration. By using these two, how we will integrate the sensor and actuators also will be known in this IoT. And compared to IoT architectures and data management frameworks, and design of IoT system for real world applications. Here also we have studied about the real world application. By studying this module 5, we will get whatever the different applications in the agriculture and the healthcare and smart cities. We'll know in the module 5. So coming to the modules, what we have the different modules. Out of 5 modules, according to the each module only, we are given 5 course outcomes and 5 course objectives. So if you coming to the course outcomes, what is this? We are knowing the characteristics of IoT, nothing but the module 1, deliberate IoT introduction, means what is IoT, introduction and definition of IoT, and what is how the evaluation of IoT will happen, IoT evaluation and IoT growth, how it is growing on, and application areas of IoT, and characteristics of IoT, and what is the IoT stacks and enabling technologies. If you see here, that only you have integrated here also in the course outcomes. And then IoT levels and sensing and actuation, and what are the different types of sensing types you have, means like touch sensing, like that you have different type of sensing techniques also will be known in this first unit only. And coming to the module 2, here it is a relationship between mission to mission by using an IoT. If you see here, module 2 is IoT and M to M, capital M to capital M, means what mission to mission, the shortcut is M to M. And if you M to M to IoT, a basic perspective, means how the IoT will be enabled for a mission to mission. And interaction, difference and similarities between M2M and IoT and SDN and NF, different networks and M2M value chains and IoT value chains and emerging industrial structures of IoT, and then the international driven global value chains and global information monopolies. And coming to the third unit, IoT hands-on, nothing but in this unit, if you can I say that it is like a practical section. In IoT third unit, totally a practical section. Coming to here, introduction to Arduino programming and introduction to sensors, actuators with Arduino, and introduction to Python programming, introduction to Raspberry Pi, and interfacing Raspberry Pi with the basic peripherals. Means already you know that peripherals are the main input output devices, and the implementation of IoT with the Raspberry Pi. And coming to the fourth and fifth module, here IoT architecture and IoT system design will be known. And here the IoT architecture, what are the IoT architecture and what are the different components it has, and comparing IoT architecture components and a simplified IoT architecture, how, and the core IoT functional stack, and also IoT data management and compute stack. And coming to the module 5, here IoT system design, here we will know about the challenges associated with the IoT. What are the different challenges you have to face before using the IoT? Any internet thing, if you connect any two devices by using the IoT, what are the challenges you have to face? Means like noise or anything, any electronic by connecting these two missions by using IoT, what are the challenges you have? And emerging pillars of IoT, what are the emerging pillars for getting this much of famous in the IoT? And then agricultures of IoT and vehicular IoT and healthcare IoT and smart cities, transportation and logistics, all are depending upon this IoT system of designs only. And how these are depending upon those will be known in that fifth unit, or the applications of that will know in the module 5. So for this, for the theoretical knowledge, what are the textbooks and reference books we have to follow for the studying this IoT system design? We have 2 textbooks and 3 reference books. Coming to the first textbook, Sudeep Mishra and another Mukherjee and Ajit Roy. It is a book, Introduction to the IoT, and it is written by Cambridge University Press. And then coming to the second textbook, David Hans and etc. And this is the networking technology protocols and use cases for IoT and Cisco Press. And reference books are the Kuno Pisister and Francis da Costa and Internet of Things, Concept of Applications and Willy. And this is the textbooks and reference books. So we have 2 textbooks in and 3 reference books. And coming to the electronic resources, means whatever the, if unable to get these books, nowadays e-learning is more famous now, so that's why you are including what are the electronic resources you have in for studying this IoT system design. You have that electronic resources and material online. What are the materials online you have, and what are the electronic resources you have? Through Anvayar, you know that these are the course template and question banks. Already we will communicate with you in live sections. And these are the different electronic resources and the question bank and tech talk, concept topics, open-ended experiments, and definition and terminology, assignments. What are the different assignments for the each unit you have done? And those will be a online materials in online. Means in Anvaya, model question paper 1, 2, and lecture notes and different ICT videos. And this is the about OBE, means outcome based education. What we are learning from this IoT system design till now we have studied. So before going to these depth concepts of IoT, first I want to introduce what is IoT and how it works, and what is IoT ecosystem, and what are the real world examples of this IoT we'll see in this section only. Coming to the IoT, what is IoT? Already the starting section only have told that IoT, Internet of Things, it is nothing but a connection of 2 machines. If you coming to the definitions of IoT here, is a vast network of physical objects such as appliances, vehicles, and machinery embedded with sensors, software, and connectivity. These technologies allows everyday item to collect, share, and act upon data automatically without requiring direct human to human or human to computer interaction. Means IoT is a system which is used to communicate any two devices without any human to human interaction or human to computer interaction. So, this is nothing but an IoT. How it works? IoT system relies on a seamless cycle of communication. How it works means sense any IoT system should be made up of sensors and actuators, Raspberry Pis, and different IoT embedded components. And here, if you're coming to the sensors and devices, it's a physical object collects data about their environment. Example, temperature or monitor a user's habits. Like that, sensors and will actuate the temperature here. Connectivity. Devices transmit this data securely over wireless networks like Wi-Fi, Bluetooth, or 5G technology. And data processing. This will work by using this cloud computing or edge computing platforms and analyze the received data. And action. What is the action? Based on the processed data, the system triggers an automatic response such as adjusting a thermostat or sending a mobile alert. By using this IoT only, it is also possible. What are the different real world examples and means in which field we are using IoT? Means not only in teaching and not only in industry, not only in the real world. What are the different applications in the different scenarios? Coming to the here, consumer IoTs like our using gadgets, electronic gadgets you're using now, those are like consumer. What are the consumer IoTs? Smart home devices. What are the smart home devices like thermostats, robot vacuums, wearable fitness trackers, and smart lighting systems? These are the different consumer IoTs. And coming to the commercial IoTs, automated inventory tracking in retail stores and smart shopping containers that track location and temperature in transit. Already we know all these devices, but we don't know these are under the control of IoT. These are the techniques. And industrial IoT, nothing but IoT is a machinery in smart factories that detects parts needing replacement or agriculture sensors that monitor soil moisture. It will measure the soil moistureness. How it is soil is a soil moisture. It is dried or wet. Like that, it will use it in the agriculture scenario also. Coming to why this IoT matters this much means by turning passive physical objects into smarter means it is decreasing our human efficiency is decreasing means it is easy to work with the any technology now. So here the work technology is increasing, the work done is increasing, but the human interaction is decreasing means it is very easy to operate a human. So by turning passive physical objects into smart data gathering entities, and IoT drives convenience, efficiency, and automated decision making without any human interaction. That's why IoT matters that much of compared to the other type of technologies. So this is the basic IoT ecosystem. This is the basic IoT ecosystem. How? If you see here in the middle, you have the internet, and this internet will communicate all the devices. If you come here, the data management and data repositories and communication interfaces and web applications, and these will be communicated with the users and actuators, microcontroller and sensors and environment. This is IoT ecosystem. Okay, so this is the basic IoT ecosystem. In detail, every component of the IoT ecosystem will explain in the next class. This is the today's class, and thank you. Thank you.